Hello everyone. So we are going to be doing a coding kata today. We're going to be taking a look at a well-known coding kata to calculate a bowling game score. So I like coding katas, helps you warm up, do some exercises, and just practice. When you're coding at your job, you're really focused on creating production-ready code. And coding kata is just a nice, calm place to practice. So we're going to start off in a blank repository. I will be doing this in JavaScript, and I will be using just as our test runner. So let's install that. In the meantime, let me create my source file and also my test file. Okay. So for this coding kata, something that I want to personally improve on is my Vim shortcuts. So I'm using VS Code with a Vim plugin, and I just want to get a little more competent and familiar with the Vim shortcuts. Okay, so let's see if this actually works. And it should complain that there are no tests. Perfect. So with this coding kata, we're also going to be doing some test-driven development. Okay. So let's have a first test case. Let's say should score all gutter balls. And we'll have this scorecard, which is a string that represents what a bowling score card should be. Let me just pull up scorecard, pull up an example. I think this is a good one. So we'll have a string. The X's will represent strikes. This person got a perfect game, so that's not a good example. Here we go. So here we see that they hit 8 pins in the first roll. The dash means that they got 0 pins. The slash here means that they had a spare. So in the first roll of the frame, they rolled and hit 9 pins. Following one, they hit the remaining 1 pin. Cool. So that's a nice bowling overview. So a gutter ball will just look like this. Just dash dash. So they hit 0 pins. I'm going to use Vim shortcut, and let's see how this goes. Nice. And let's say we have a function just called score. It's going to take the scorecard as an argument. This should return 0. Let's actually run just in watch mode. What this will do is just will continuously rerun our tests whenever any of our source files change. Again, score is not defined, sense because we haven't created the function yet. So we're going to import that. Just to go nice and slow with TDD, let's just see what the next error is. The score is not a function. So let's create the function. And the next error is that it received undefined when it should have been 0. So let's return 0 and the test pass. So let's come up with another test case. Should score 1 roll, let's say. Scorecard is going to be, let's just say we have nice 1 over here. Let's say we hit 1 pin in every frame. So I would expect this to have a score of 10. Save. Okay, so let's handle this use case. So test-driven development, usually go through this red, green, refactor stage. So red is our test is just failing. We see the red here. Green is us trying to get the test to pass as quick and dirty as possible. And the refactor is to clean up our code. So with this, we have to take our scorecard argument. For this, let's break down the scorecard into frames. So there's going to be 10 frames in the scorecard. If we do scorecard split, that's going to give us an array of 10 strings. And let's iterate through each of those strings, each of those frames. I have a score variable here. The score will get increased by the first elements of the current frame. So returning 0 here, let's return the score. If we look at our test, you can see not a number, which makes sense because these dashes are going to parse int and it's returning not a number. So here we could do something like, let's see if this works. Perfect. So if parse int returns not a number, we're going to return 0 instead. So this is the green part of red-green refactor. So let us do the refactoring. We could probably name our variables a little bit better. So we could do current frame. Current frame. So it still passes. We could probably do first roll. First roll. And I am pretty pleased with what we have so far. There's also some refactoring we can do in our test. So we should treat our test code more or less with the same focus that we have on our source code. Here you notice there's just some repetition here just replacing the scorecard and running the same function. So what we could do is create scorecard correctly. You have this test. It's going to have a bunch of scenarios. Scenario will be have a scorecard. And then it will have an expected result. Let's just format this. So we're going to iterate through each of these scenarios, and we're going to make assertions on these scenarios. So we're going to expect score scenario scorecard to equal scenario results. Those all pass. So now we can delete these tests until some destructuring here. So I could take scorecard and results. Destructure is it like so. Perfect. So now let us keep adding more scenarios. So the next one we could probably do is the second frame. So in each of the frames, they're going to hit 1 pin on the first roll, 2 pins on the second. So I expect 3 pins over 10 frames. We should have 30 points. So we add a new test. We see it's red. So let's go refactor it. So let's just write the quickest code we can to get this working. Nice. So this works. Try to see if we can clean this up a little bit. I see some duplication here, which is pretty much with this roll. If it's a dash, we have to treat it like a 0. So yeah, let's refactor that. So we could do something like process roll, maybe score roll. Let's do that. So score roll. Nice. I think that is good for now. Let's add another use case. I think we could get a little more complicated now. So let us handle spares. So this is a spare, have different numbers, 7 slash. So this means they hit 7 pins on the first throw, and they hit the remaining 3 pins on the second roll. They've hit nothing else. So how is this scored? This will be 10 points plus the value of the next roll. So right now we just expect a score of 10. We see we only receive a score of 7, which makes sense. And that's because here we are processing the slash here, just a regular 0. So frames isn't really the correct abstraction. We should probably be thinking in terms of rolls. Like how many rolls did you do? So here we could see they did 20 rolls. So let's break out our score card set of frames, where we have 10 frames, into rolls, where we have 20 rolls. So rolls, let's probably just do a quick for loop. So this element could be a number. It's a number, that's good. Just going to push that number through. It could also be this dash. So we're just going to push in 0. Now we saw it could also be slash. So this is an interesting use case. What should the value be for the slash? So it should be the previous roll so that's going to get us the most recent roll. And we should subtract 10 from it. Oops. So how do we handle the score? So now we're going to iterate through every roll. And just add up the score. Let's see if this works. So yeah, one of the bad things about doing the scenario this way is we do not get good error messages. Just wondering if in jest we can write better error messages. Just error message expect. Yeah, so unfortunately, I'm wondering if we should break these scenarios out into its own test cases. We could also do something a little dirty. I haven't actually tried this. Let's see if this works. So that's the same. We can do a console assert score results. Otherwise. So console asserts if this is truthy, does nothing. If it's false, C. It will print out a message. The message we care about is probably just the scorecard. And probably have to put it on top of the expect statement so that it gets called. Okay, so this helps a little bit. Kind of wish Jest had a way of doing it. It might. So it's just failing on the very first one. I have an idea. We're not handling blank cases. So if current elements is just blank, should do nothing. So let's just do a continue. Did that fix the bug? Yes. Perfect. So we got the green, so let us refactor. So we're not using frames anymore. We're also not using this score roll anymore. So we're creating all of this roll information. Let's move that into a separate function. Create roll array. So in the score function, we get all of the roll information, and then we just iterate through it and score. Cool. So let's add another use case. Here. So what should the score be? So this should be 10 plus 7 from the spare, and then 7 again. So 17 plus 7, I think 24. Cool. So how can we handle this? So inside our roles information, we have to check if the current role and the next role are a spare. So when we're doing this roles, we should actually increment by 2. Because we're dealing with both roles, and we are also dealing with frames, which we might use later on. So let's do score plus equal roles I plus 1. Let's see if all the tests pass except the last one. Yes. So we want to check if our current two roles are a spare. So we do that by checking if the current role and the next role knock down 10 pins. If it did, we want to increase the score by 10. We also want to add the next role. Otherwise, do this. Works. So let's refactor this spare to its own variable. And I like that. So on to the next scenario. Let's do a larger one. So here, they got all spares for 10 frames, and with polling, you get to do one more roll. So let's say they got another 7 here. So my math says that this should be 17 times 10 and 70. So let's see if that works. Okay. So it breaks on this last one. And it's because for this last roll, now we have an odd number of rolls. We actually expected 20, but in bowling, you get some extra frames, extra rolls in the last frame if you had a spare. So we actually have 21 rolls. And because of that, I plus 1 is actually undefined. For this 21st roll. So what do we want to do? We want to keep track of frame index. We want to increment it and we want to break out of it on frame index. So this says we're only going to play 10 frames. That works. So refactoring, we have a magic number here, 10. So let's extract that out into a constant called frame length. This initialization we could probably put in here. Or not. Oh. Not too crazy about this. Just with for loops, it's more idiomatic just to have one counter variable. Now we're actually counting this I, this frame index. You don't see this a lot with for loops. one way we could make it better here is, rename, let's call it role index. It's a little bit less confusing about what I references. Still not too crazy about it, considering doing a while loop. So let's add one more scenario and see if there's more room to refactor later on. I think the next case is just a strike. So a strike, you just have one roll for the frame, and it by itself is worth 10 points, and then you calculate the next two rolls. So in this instance, it's just going to be 10 points plus 0 plus 0. We wrote our test. Let's look at the test case, which should be failing. Let's make it pass. So I know in the create roles array, we're not handling the strike condition. So let us do that. So if it's a strike, I'm just going to add a 10 to the roll. And now we have an issue here. We expect that we always roll 2 times in each frame, but for a strike, we actually only roll once per frame. So we got to change this logic. Let's pull the roll index. 2. So when we roll a spare, or I don't know what you call a non-spare, non-strike, just regular rolls, we're going to use up 2 rolls. But if it is a strike, it just means the current roll is 10. I'm going to just use up 1 roll, and we're going to break out. Nice. So refactoring, so let's have a is strike variable. Let's use the same pattern here with continue. Similar to is strike. Cool. This is looking good. Function's getting a little bit long. So let's handle, I think we only have 2 more scenarios. So let's handle this scenario where we have 2 on a 4, let's say. So our score here should be 10 plus 6, which is 16 for this frame, plus 6, so 22. So when it is a strike, we're not just incrementing it by 10, we're also incrementing it by the next row and the row after that. Nice. And the last test case is the perfect game. Whoops. Yes. 4, 5, 6, 7, 8, 9, 10. Whoops. So on the last frame, we assume they hit a strike, so they get to roll 2 more times. They hit strikes again. So this should be 300. Next. So that should be all of our test cases. So now it's time to refactor. It's a little bit cluttered here with some duplication. So one thing we could take out is the isStrike and isSpare functions. So we should have a function isStrike, and it'll take the roll information. We could also have isSpare. So we could call it like this. Nice. So we move that logic into its own functions. And here we are just specifying what the score outcome, how much to increment the score by, and how much to increment the roll index by. So what if we had a function that looked like this? Calculate strike rolls index, and say it returns an array. The first element is the score. So score 10. For strike, it's going to be 10 plus the next 2 rolls. Just copy down. Score. And then the second element will be 1. And this 1 represents how many rolls you're using up. So score offset, let's say, and roll offset. Calculate strike. Increase the score and increase the roll index. So let's see if that works. Nice. We'll delete this. Let's move this function out. Here. Beautiful. And we can do something similar with the spares. I'm just going to copy calculate strike. This will be calculate spare. It's going to increment by 10. And it's going to use up the next roll. It's going to use up 2 rolls. So let's see if this works. Beautiful. So there's also some repetition here. So we could sort of invert the logic. Let's say the score offsets is rules. So just these two. That's our default score offsets. Default roll offsets is 2. Then we could say score plus equals score offsets, roll offsets, roll index plus equals roll offset. I think this might break. Might have to do something like this. That's just because we can't have the variables being the same, which is unfortunate. I wonder if there's a better way of doing it. We also have an issue here. Let's see if we can find it. Score offsets, roll offsets. Let's see which one is broken. So it is the strike. I wonder. So let's back it up. Let's see. So this still works. So yeah, I'm wondering if this might be better, because first thing you do want to do is check for a strike. I want to add some consistency here. So we'll have a calculate normal frame. Score will be the two rolls, and the roll offsets will be 2 because it's using up 2 rolls. So this should work. And one thing I would like to do is get rid of these, which is repeated so many times. This might actually be the cleanest way. So we can get rid of all these continues. Instead, make it else, if, else if branch. Kind of do what we did before. Let's see. I think this will be a good stopping point. Every time you do these katas, you can really refactor to your heart's content. But I think this will be a good stopping point. I might play around with this a little bit more. But yeah, next up I will try to put out another coding kata and see what happens.